No, not you, Charles.
Hi, good morning, everyone. Welcome back to session 3 on green energy. We've had a few weeks talking about sort of the challenges that lay ahead in South Africa, or really not ahead, also behind, with load shedding, and where the opportunities and challenges looking forward. And then looking at, how is, Southern Africa involved or potentially got opportunities from the mining side of things to join the sort of global energy transition in terms of raw material supply. And today we're going to jump on and look further into green energy solutions for mid-tier mines and industrial businesses. So I think these are all key topics, and they're not, for South Africa and us South Africans here, it's quite specific with regards to just keeping the lights on in terms of energy security. But just sort of an anecdotal comment to lead into this presentation today is, we've had energy crisis in Europe because of the Russian-Ukraine conflict, rising energy costs in China, and feed to run large industrial businesses in India. So the energy conversation is a global one. And just recently we had an energy storage facility. There's a publication on that from this week, where the UK has sort of fast-tracked an energy storage system to help support domestic grids using wind energy and supporting energy supply to houses because of this energy crisis. And that's all been done without government support. And so because that's not in place, it requires private investment. So South Africa is in a similar boat, although with a lot longer track record of experience in not living with energy. So very interested to welcome Charles, Avi, and Willem to hear what they have to say about how they've been involved in the sector. And I'm going to let the three of them give a quick introduction to who they are and why they are here. So over to the three of you. Thank you very much, and we're looking forward to hearing the presentation.
Well, thank you very much. My name is Charles Mostert. Good morning to everybody. I'm Managing Director of a South African EPC solar company called Sunron Solar. We did present to this forum approximately a year ago, and we really appreciate and we're privileged today to give you an update as to what's transpired in our company. But suffice to say, you will see from the presentation today that the company has experienced significant growth. And obviously, I think everybody will understand what underpins that growth. I will be assisted by Willem Mostert. He's our Operations Director, and also Avi Bosman, who is our Senior Project Engineer. So with that, we've got quite a lot of slides to cover this morning. Quite a lot of presentation material, so I'm going to start and then hand over to Willem and then to Avi. We've timed it, Niels, for about 45 minutes, which will leave about 15 minutes for any questions and answers. So just on the first slide, one can see from that slide just our accreditation. Sunron is a fully accredited EPCM solar provider, also with battery storage facilities. And I'm not going to go into all the accreditation. Suffice to say that from an accreditation point of view, I think we carry all the permits and the accreditations required. We're also a Tesla Energy certified installer. So for the gentleman from the USA, we actually went to the US and wrote the Tesla exams, which was a experience in itself. Willem, if we can move to the next slide. Just with regards to the perfect storm, we thought we'd put a teaser out there so that if one doesn't fully understand what the topic is all about, then obviously hopefully it attracts a lot of attention. Now, some of you may remember, so just on the agenda, we'll go through that. I'll do the perfect storm section. Willem will do the company profile and value added, and then we'll close off with Avi, looking way to the future and particularly battery energy storage. Willem, next slide. Thank you. I hope most of you will remember in the year 2000, there was a Hollywood movie called The Perfect Storm. And the cast was just about a dream team of Hollywood actors. It was actually based on a true story of a swordfish boat, fishing boat, that went out on the Grand Banks in Newfoundland. And cut story short, it was hit by Hurricane Grace. And as the recollection goes, a freak 40-foot wave turned the boat, and there were no survivors. Very tragic story. Good Hollywood movie, very suspenseful. And there's definitely an analogy between what happened in this rough seas and what we're experiencing in the South African energy sector of today. And there are really, from our point of view, 3 points, three factors that have created a tipping point in energy supply today. And those three are, and I'm going to cover them in detail. First one is Eskom load shedding. Second item is the increase in the cost of grid power. And then, to surpass it all, and on top of everything, is our fuel price increases. So, Willem, if you go to the next slide, we'll cover the first factor, Eskom load shedding. Ladies, gentlemen, this is the horrific news from Eskom. It's in the public domain. I'm sure that the audience today is well aware of it, but I'm going to cover it anyway. If one looks at the first slide, hours of load shedding, that's the graph on your left-hand side, you'll see that since 2019, we've had a terrific increase in incidence of load shedding. This slide is now an old slide because in the narrative below, it says that South Africa has lost 81 days. I believe it's now 101 days. That's working days that we've lost to load shedding, obviously having a significant negative impact on productivity in South Africa. Reading in conjunction with that, if we look at the left-hand slide or the right-hand slide, is the energy availability factor of Eskom's power stations. And we see quite a significant downturn from 2018. Right now, we're sitting at 53.16% of availability. Eskom has got a nameplate capacity, that's generating capacity, of about 40 gigawatt. And right now, we're producing just over 20 gigawatts. So power plant utilization really down. And everybody understands that these are old ladies, these coal-fired power stations. Some of them are 35 years plus. And they're slowly but surely being withdrawn from the grid. Some cynical news from quite a number of news sources. You can see there from News 24, government announced that we need 53 gigawatt in 10 years, but we've battled to add 9 gigawatt in 15 years. So significant challenge going forward in order to balance supply with demand. And then what we're experiencing right now is the phase 3, phase 4, even phase 5 load shedding. Eskom announcements coming out seem to contradict each other. The first sort of set of announcements was that we're going to experience a minimum of phase 3 load shedding for the next 12 months. Now that's been extended to 24 months. So one has got to read between the lines, but very clearly that Eskom faces a significant dilemma. So that's the first contributing factor to our perfect energy storm. Item number 2, Willem, change the slide. Second factor has been increase in power tariffs, and you'll see a graph there. My source is Alta. From 2008, we were running at some of the cheapest power globally, 19 South African cents per kilowatt hour. That has increased in 2022 to R1.28, about a 560% increase over this period. And obviously looking forward, we see the approaches that Eskom has made to NERSA. First approach for the next financial year is a 32% application for tariff increases. One is not sure what NERSA is going to approve or not. Diesel costs, up to about a month ago, the lights were kept on with diesel generators, and Eskom subsequently made an announcement that the budget for diesel purchases, that budget has been exhausted. There will be no further diesel purchases, and hence this increase in the phases of load shedding. And then to compound that, obviously, quite a number of users of Eskom electricity, in particularly certain of the municipalities that just don't have the ability to pay. So it's all free power. So not a nice position for the Eskom board to be in, and obviously they've got quite a number of serious issues to contend with. That is the second item. We'll come back later. Avi will cover the value that we bring to our customers, because it's not all that dark. There's certainly solutions to the Eskom tariffs by providing cheaper and more reliable power. Third factor, just to overlay everything that we've covered, is South African petrol prices, mainly due to OPEC costs, but also to a devaluation of the South African rand when compared to the US dollar. And as you can see there, in the past 5 years, our fuel prices have more than doubled, and we continuously see an increase in the fuel price. That is as an introduction, just to provide some background to some of the important items in the energy industry in South Africa. These items are certainly not all that's contributed. I'm sure that there are many more, but these are the three that we picked out that we feel have had the most dramatic impact on energy pricing in South Africa. If we go to the next slide. Willem, I hope you can hear me. If you can turn the slide.
Yes, sorry, I was busy.
Okay. Okay, Willem, I hand over now to you to discuss with the audience the value proposition of SunRanch. You will cover just very briefly who we are, and then what is our contribution to power users in South Africa. Over to you, thank you.
Thank you very much, Charles. Good morning, everyone. My name is Willem Mostert, as Charles mentioned. Thank you so much for the opportunity to present today. I'm just going to take you through a brief 2 slides just on who SunRanch Solar is. So SunRanch was established in 2015. We commenced with business in 2016. So we are relatively new to the renewable energy industry, but we have seen vigorous growth over the past 7 years, despite also being in the COVID situation. The company business plan and our value add to our customers, we're focusing on our four Ps. The first one will be a power partner. We see ourselves not as a installation, but as a long-term, reliable power partner to our customers. Our pricing, we offer also the best quality solutions at competitive pricing and also against the current grid power tariffs. Power security, the last, I would say, 1.5 to 2 years have actually become a major point. In the past, we've seen our customers only focusing on the most affordable power solutions. But with, as Charles mentioned in the previous slides, with the current situation that we're in, our customers are not only focusing on the most affordable power, but also reliable power. What our customers are currently facing is that their generators are running not as a backup solution, but as a main power solution. And the cost that they also, the profits and income that they're losing in terms of the load shedding that we're experiencing, our customers are also now looking at reliable power. not just that, but also the quality of power that we see. Our rural clients are experiencing a lot of spikes that also causes their machinery failure, and they're looking at also clean energy. Our performance capacity, what we have done in the past 2 years, is really focusing on building SunRanch to be a one-stop shop, and I will go into much more detail in the next slide in that one. Our SunRanch strategy going forward. Now, the renewable space is a very large space, so we had to be focused on to say which areas do we want to be part of. So we identified 3 areas. The first one we call our stock standard solar solutions. So that is our bread and butter of the company. That will be our straightforward grid-tied solutions, most affordable power, and also your quickest payback. The second one will be our battery energy storage systems to give reliable power, and Ari will cover that one. And then the third, as we saw in the previous slide, we've got a huge demand trying to build this 52 gigawatts, and government has turned to the private sector for assistance. So we're also focusing on solar parks to get solar parks designed, build ready, finance, and also installations of major solar parks. The company itself, we actually got a very nice story the last 3 years. We managed to double our profits from 2021 to 2022 and did the same for 2022 and 2023. Going forward, what we've realized for the next 12 months, we can increase our turnover by 5 times with current contracts that are already signed. And this is also taking in consideration that for 2 years we actually were in the COVID period and also were able to do a lot of installations during that period. The next one that I'm also just going to focus on is SunRanch itself. So we are a one-stop EPC solar company. We're focusing on our smaller scale projects, that will be our 150 to 1 megawatt projects, and also on our larger scale projects. We've got the capacity from the engineering side that we beefed up in the last 12 months to get qualified electrical engineers who can do the designs of simplistic grid-tied systems to more complex systems. We've got integration with base, generator, and the grid. So our engineering department is state-of-the-art in terms of their capacity to do the designs. From an installation side, we've got our own installation teams that are able to do the installations, and also moving on from the installations, we also do the O&M and of the PV systems. We've done numerous installations in the industry. We've done your high volts, low volts, switchgear, internal lines that we have built. So what we focused on is to be a one-stop shop. Just in terms of the mining sector more specifically, and I'm just going to take you quickly through the financial model of one of the mines that we're busy with in terms of negotiations with the PV system in the Rustenburg area. And just to highlight a couple of points. The one thing that what we have identified in the mining sector is that the PV solution for the mining sector usually is sometimes a little bit higher than your other industries due to the fact that your mid to larger scale mining operations don't use LV power. And when I mean LV power, it's your 400 volt power. The machinery that your mid to larger scale operations use is either 6 kV or 11 kV power. Your solar solution produces power at 400. So there's additional equipment that needs to be installed to step up the volts to be able to supply the mine with that power. So with that taken in consideration, your capex cost for mining operations tend to be always a little bit higher than what you will have, for instance, your factories and etc. that runs on your LV. So to start off with just the quick numbers, the current price for grid power for this mine is at R1.65. With bank finance producing the PV power, we can reduce the PV cost is at 53 cents. That is a deduction of 68% in the electrical cost. Going on just from a more financial point of view, a PV system, and this is what this is going back just a couple of slides. This is our stock standard bread and butter. It's actually a no-brainer. You're sitting with an internal rate IRR of 30.69% with bank finance. Moving on just to a couple of examples that we have in the mining sector itself. This is an installation that we did for Syferfontein Carbonates. It's Mupani mine up in Limpopo province. Now, this system is phase 1. Now, this is to reduce the electrical bill drastically. So this system itself runs with solar power that operates the entire plant. Together with this is a genset integration unit. What the genset integration unit does is, as soon as load shedding occurs, the majority of power is being supplied by the solar system should there be sunlight. So your generator will idle in between 10 to 40% on idle, and the solar system will produce the remaining power as the sun shines. So you have a massive fuel saver on this one. Phase 2 of the system going forward will be the installation of the base system. Next slide that we have is a very interesting project that we're currently busy with, and also already designed and built in phases. This is Afrimat's Glen Douglas mine, located just outside Johannesburg. With the system that we had, we're also looking at the area available on the land and also the different technologies currently that's available in the renewable energy space. So looking at a couple of areas and also options available for us, we did calculations in terms of the best possible production that we can get out of a certain section. So the Afrimat design is based on a Schletter tracking system, which tracks the sun. The Schletter tracking system will be the first Schletter tracking system installed in South Africa. The tracking system also has the new JA bifacial solar panels. So what the bifacial solar panel does, it's also got wafers at the back of the panels, which increase the production from the reflection of the sun from the ground. Because this is a dolomite mine, we actually got a lot of white rock. So as soon as we're done with the installation of the poles, that's going to be scheduled for January, we're going to bring in white rock that's going to be laid onto the ground. That's going to increase the reflection from the ground. That will increase the production of the solar plant. In total, we expect a 26.9% increase with the bifacial solar panels. And putting that onto a tracking system, we can increase the area of production to 32% in total. Now, what we've seen, and this is just one thing that I want to highlight before I hand over to Arvi, is each and every one of our clients are different, and different approaches are also taken to, first of all, understand what is our client's needs. The difference between, for instance, Afrimat and when we talk about Syferfontein is they're all set in phase installations, but the difference that we have is that the needs for Afrimat is also based on an 11 kVA grid connection, where Syferfontein is on a low volt. Afrimat itself got different load profiles. We based on Eskom as well, so we have got the ability to also push back electricity on a Saturday and Sunday when the mine is not in operation. Phase 2 for this installation will be additional 1.2 megawatt system with a 4 megawatt battery system. And on the battery system, I'm going to hand over to Arvi just to talk more about the energy storage. As you can see in the previous slides, that the current focus is not just on the affordable power, but also about reliable power. Thanks. Handing over to you, Arvi.
Thank you very much, Willem. Okay, so looking at the battery energy storage solutions, there's basically 5 drivers that drives BESS. And the first one would be the high incidence of load shedding in South Africa, and that would affect all businesses in the country. Now, unlike the USA and Europe, South Africa is not a gas-powered economy. So for backup, we need to rely on diesel. Now, diesel, as previously mentioned, the prices are just going up and up and up and up. So your operational cost for your backup system is extremely high. What helps a lot is the decreased cost of the battery power. The battery systems keeps on getting cheaper by the year, so it is becoming a viable solution. And obviously, the last one there would be customer requirements, or they require a reliable and continuous power supply for obvious reasons. Now, these BESS systems are still on the expensive side. If we look at capital cost of these, it is large and higher than normal grid-tied power systems. So what we offer is a power purchase agreement or a PPA with the BESS systems. Now, we've got a couple of repeat customers who've given us the go-ahead for the BESS, and we offer these PPAs on systems larger than a megawatt. Now, benefit of this to the customer is there's no upfront capital cost. The financier owns and maintains the PV plant and then just supplies the power to the customer. And we're looking at terms around about 15 years. And it's very competitive if you compare it to the grid power. Due to the nature of the PPA, the performance guarantee is included in this. And there's a buyout provision after 3 years and at the anniversary of every year thereafter. And then after 15 years, there's a free transfer of ownership. If we look at the value add and we look at starting off on the PV side, a PV will cost you.
Yes. Sorry to interrupt. Your video obscures. I don't know whether that helps for everybody else, but it obscures that block. There we go. Thank you.
Thank you, Charles. So the value add that SunRanch can give is we're looking at the PV power of between 35 and 55 cents per kilowatt hour, which is a lot cheaper than Eskom's R1.70 on average. For battery energy storage, we look at R2.50 per kilowatt hour, and then diesel backup, we're currently looking at R5.80 per kilowatt hour, and some systems are even higher than that. Now, a very important point to consider when looking at BESS is you have to consider all 4 of these elements. So you can't just look at purely PV and BESS because Eskom, believe it or not, is still cheaper than that combination. Diesel gensets are still necessary because of reasons that we will look in the next slide. Willem, if you can go over to the next slide, please. As Willem mentioned, each and every single client is different. So we start off with modeling the system to the client's load profile. So this specific client has got continuous operation 7 days a week. And we modeled, if you look at the left-hand graph, that is his weekly simulated power consumption. What we currently have in South Africa is a high incidence of grid unavailability, and that is simulated on the right-hand side of your screen. Now, this simulation is more or less 840 hours of grid downtime from Eskom. So this would cater for the 2020 scenario for the annual load shedding. Now, what we do, and as you can see, there's certain times of the year where the power is relatively constant and it's there. But then suddenly you get a couple of dips and we go into a month or 2 months, or a week or 2 weeks of continuous load shedding. And then there's constant power again for a couple of weeks after that. Now, the thing about batteries is you need to use it. Otherwise, that R2.50 that I quoted you earlier, that cost is going to go up. So what we do in designing the system is make sure that we cycle the battery at least once every single day to get you to that R2.50 per kilowatt hour. And Willem, the next slide, when we look at the losses, you'll see what I mean there. So the Sankey diagram gives us all the losses of the BESS system. But what I want to focus on is that bottom part. So, and that is highlighted on the right-hand side of your screen. So on the PV and the battery energy storage side, we supply through batteries and PV 11.4 gigawatt hours of energy annually to the client. 17.1 gigawatt hours would come from Eskom in this case. But now what happens is, because we cycle this battery daily, there might be times when there's load shedding on very short notice, which we weren't aware of, and we couldn't plan and make sure that the system is ready for that. So there's around about 0.5, 0.6 gigawatt hours annually unaccounted for, which the customer would need. Now that is where a generator would come in, and during those parts of the year, the generator would supply the power. So a system like this would give you a very good match between your CapEx and your OpEx. Willem, if we can go to the next slide, please.
Willem, are you there? Willem, are you still with us? Oh, it sounds like we have lost him.
It sounds like that, yes. Should I quickly try to share my screen on my side?
Yes. The next slide showing all these? Showing on my screen? Yes, I'm here.
It's not showing it. There we go. Thank you, Willem. So looking at the future sustainability of the company, we've got a very good pipeline of projects going forward. So our signed and go-ahead contracts where we've got a very high confidence level is 8.6 megawatt peak worth of PV and almost 13 megawatt hours of BESS, battery backup. Looking down to the short-term future, we've got 780 kilowatt peak worth of projects. And then going longer term, we've looked at category 2 projects. We've got 90 megawatts of projects of a relatively high confidence level. Now this does include our 80 megawatt peak solar farm that we are currently looking at and developing. And then going further than that, we have 32 megawatt worth of projects going into the future. And that is from me. Thank you very much.
Harvey, Willem, thank you very much. If we can hand over to the chairman, please, for any questions or answers or any comments from anybody else.
Yes, thank you. Thank you, Charles. Thank you, Willem. Thank you, Avi, for that presentation on what you've been doing. I mean, it marries in quite nicely to the discussions we were having over the last 2 weeks, specifically 2 weeks ago, looking at the issues that Eskom has, and based on what we were showing then, the downtime that you've shown in your model here seems like it might be getting worse. So I'm curious. Be interesting to rerun those models in terms of the requirements on battery capacity in a sort of worse scenario. So in terms of, we've got a couple of questions here. Again, if anyone is keen to ask her questions directly, please just turn on your video or raise your hand and I can call you out. But in the meantime, we've got one from Andy Clay asking in here, why aren't all renewable components made locally? Anyone would like to take that?
Yeah, sure. It's Charles here. Good morning, Andy. Trust you are well.
Yeah, hi, Charles. Good to see you again.
Yeah, thanks for the question. Andy, very shortly, the pricing from India, and particularly also from China, we find that nobody can beat them. All our imported stuff is tier one Bloomberg certified. and you get panels such as Canadian Solar and other US manufacturers. But the manufacturing actually takes place in China under a US license. We do have one factory in South Africa and New Germany, in KZN, but they are an assembler, so they import all the panel parts and assemble that. But as far as we know, the South African market is too small, and our pricing is just way above when compared to the scale of economies in China.
But Charles, that just goes to show you how pathetic the government is with regards to anything to do with strategy, because they could easily sort this problem out. I mean, most of the materials that go into making these things is produced here in the resource sector. Yeah. And if they included tariffs and all the rest of it, and we should become the solar factory for the whole of Africa instead of having to import things from China. But look, I mean, what you're doing is fantastic, but the government is on a different planet. I mean, why isn't the Cape, for instance, the Western Cape, allowing people that have got solar to put their power back into the grid and get paid a reasonable price for it? What you're doing is fantastic. It's just that you're an order of magnitude away from anything to do with the government.
Yeah, no, absolutely. I can only concur with you. But you know, that would really be for the politicians to decide on.
Oh, come on, Charles! I've never known you to be so PC.
Gotta count my words.
We won't tell.
Yeah.
Maybe just to follow on in there. Yeah, just quickly, Andy, your other question was talking about the costs. We've got a couple in here, also from Alan, asking, how do you get to 35 to 55 cents per kilowatt hours? And then Andy, you were asking, is that after depreciation? I think that really comes into sort of the next part of the question. It's like, okay, we install this, there's obviously CapEx required into this. What's the life of these things? Not just the payback period, which is, as you've shown, especially if we start including battery energy systems, the payback period goes a lot further back because you're paying more on that. So, what's the lifeline of some of these materials, and do you include that depreciation cost in there?
Willem, can we turn that one to you, please?
100%. So, just first of all, to address the questions on the 35 cents and to the 55 cents, what we take into account, those numbers are a stock standard grid-tied system without any battery storage. So the panels that we have is almost 55% of the total cost of a PV system. Now, those panels are warranted for 25 years in terms of their performance, the linear guarantees on them. So what we do is we calculate the production, estimate production over 25 years, take into account O&M cost for the system, divide then the total CapEx cost and O&M to the production to get to the 35 to 55 cents. These numbers are client per client. And as I previously mentioned, as soon as you do grid integration on your large-scale projects, that will be additional capital cost on top of that project, which will increase the PV cost per kilowatt hour. So it all depends in terms of what system design and what requirements the system needs to do. Your simplistic solar solutions that won't always give you reliable power is the most affordable. But as soon as you start adding grid integration, base system, you will increase the cost per kilowatt hour. Moving on to the systems itself, the major components. Your inverters have carrying a 5-year warranty that can easily be extended, but the total inverter cost, if we look at it, is roughly 5% of the total cost. So although it always comes up as a major equipment item, is actually not in terms of the CapEx. On the battery side, now the battery side on the base system is a very interesting one. We've got a couple of suppliers in terms of batteries that we've done solutions on and running on solutions. And To give you an example, Tesla, although we are accredited by Tesla and that it's one of, I believe, also the best technologies that we have, they're not that interested or keen in the South African market, and the lead times to get the batteries are quite long. So we did a solution with Hitachi. Hitachi bought over ABB. And what you do in the design of the system is you calculate, as Alvi mentioned previously, how many times do you need to deplete the battery per day and at what discharge rate? Taking that in consideration, you can calculate the lifetime of the batteries. Usually for the batteries, we see the battery can last you all the way up to 15 years. And depending on the supply of the battery, it also determines in terms of the warranty that they're producing. Locally, we've got two battery, I won't say manufacturers, almost exactly the same as assemblers. The majority of the components are imported, but we've got Freedom One and Blue Nova that's also now focusing on your larger scale based systems. In South Africa, we've seen the storage systems actually develop quite rapidly. The focus 4 years ago was only on residential, and we didn't have really solutions for your industrial size systems. But now the market has, for the need of the market, it has grown significantly, and there are companies in South Africa producing those solutions. So I hope it addressed the questions in terms of your depreciation, the lifespan of the batteries, and how we get to the cost per kilowatt hour. Our main focus that we have and what we've seen, just to add on to these costs as well. As soon as you become a power partner with the base system and the PV system and also providing power, our clients tend to often say, guys, this is not our business. You come and install and we just purchase power from you. So what we try to do with our PPA is either to give a discount towards the current grid tariffs or to match it and also give them a focused future price increase. So we will tell our clients, for instance, sign a 10, 15-year PPA with us, and we will fix the increase at 6%, because the uncertainty of where grid prices are going is also a challenge for our clients to budget for future cost of electricity. I hope it addressed all the questions that was just on my side.
Yeah, there's lots of thoughts in there, but a couple comments there. You know, it's interesting you're talking about, you know, looking at Tesla's supply chains, and they're not, you know, really focused in on the South African market. And you know, interestingly, a good friend of mine worked for Tesla out of Betty's Bay, but you know, he ended up moving to Amsterdam because that's where all the solar work is taking place. It's in Europe right now. It addresses a key issue that, you know, when we're looking at, you know, relieving the power struggles in South Africa is a supply chain one, right? Tesla has got a backlog of battery storage where they're turning down clients, and so they have no interest in South Africa, mainly because, you know, the pricing down here is less competitive for them, and the demand is more than enough to meet what they're capable of meeting and their bottleneck is in raw material availability. So raw material availability, I still think, has an important role to play overall in this, which, you know, brings us back, you know, to the geological fundamentals that underpin this whole energy transition. So, yeah, so just adding to that. Thanks for that.
I fully agree with you. That's again, was not talking about locally and the problems that we have here, but as soon as we look at suppliers for our systems, we go back actually towards China, because that's the market that's focusing on us, and also we're getting stock from them.
Yeah, absolutely.
Available stock.
Right, we've got a few more questions popping up here. Can afford our seconds.
Niels, it's Kobus Winter here. The one thing the one thing that I'm very interested in is perhaps a little bit of a detailed thing, but that is, let's say, battery storage, because you know, let's say for 100 years, perhaps exaggerating a little bit, you know, we've been on lead acid, and now they've moved over to lithium iron phosphate. Now the thing is, I think especially from Avi, he seems to be the one on storage. You know, is the future in lithium iron phosphate batteries for storage, or will we perhaps change, let's say, another 5 years to another, let's say, battery system? You know, what is the situation regarding, let's say, storage? Because I think storage is obviously one of the most important things, because solar, helps you during the day. It helps you when the sun is shining, but during the night, you need reliable storage. So what is the situation regarding, let's say, development of new batteries and more efficient batteries and so on? I think the jump to lithium iron phosphate, I think, was already a huge jump. You can discharge them to, let's say, 10% or 0 or whatever, where lead acid, you can go to 50% maximum, and they weigh about, let's say, half or even less than the old lead acids. So I'll just be interested in hearing the comments about batteries, storage batteries.
Yeah. Avi, you keen to take that?
Yeah, Kobus, thank you very much. I think for the foreseeable future, we would stick with lithium iron phosphate. I know there's a lot of research going on in the technology at the moment, and they're looking at graphene, for instance, to improve the efficiency there. And it's also very important to note the way that the battery will be used. So the way that we use the lithium iron phosphate is for backup or for grid support or something like that, where there's constant, for a client, there's constant use of the battery. Now, if we look at larger systems, there is definitely better technology out there. So if Eskom itself needs to build a battery system where they need to do certain kinds of grid support and frequency control and that kind of thing, there's other technology like redox flow batteries, which is basically a pumping system. Those batteries then is better for that use. But for the industry where we are looking at and that kind of thing is definitely lithium iron phosphate for the foreseeable future. Obviously, just with the incremental performance increases, like in where the research goes. I hope that answered your question.
That's right. And Avi, maybe I can just add a few more comments to that. So the company that we have, Project Blue, we look at the technology landscapes and the forecast for these battery storage systems. And so Kobus, you raised two good points here. One is what is the future distribution of technology landscape, right? And lithium ion batteries has come a very, very long way in a very short amount of time over the last since 2017, when Tesla was still really focused on their aluminium cobalt versions of lithium ion batteries. And now we've gone into the nickel manganese cobalt cathode formulations, and those chemistries have continued to change, going to nickel rich, mainly related to getting rid of the cobalt from a supply chain issue again. So it becomes a supply chain conversation. And they're now going into lithium iron phosphate, specifically not used for the main electric vehicle drive because they're not as energy dense as the nickel manganese cobalt versions. So they're using for other applications. So for ESS or BESS becomes an interesting option. It has its own nuances because lithium iron phosphate recyclability is not very good. So from a sustainable perspective, that becomes a very interesting conversation. So I think we will see a lot of development in technology that will end up replacing lithium iron phosphate. But given the cost and the political drive, it is in our forecast the main technology being used over the next 10, 15 years, right? So these technological developments, we will, like Avi said, we'll see improvements in the technology, but necessarily major technological shifts that takes some time to be developed. And people are still waiting for hydrogen storage energy capacity. That seems to be where a lot of people are putting their hopes on in a longer term, beyond 2050 conversations. So yeah, it's a very good question. And then you also, the second point you mentioned lead acid batteries, right? I think here in South Africa, most of us, or not most of us, but we've been using secondhand lead acid batteries to power our PCs and Wi-Fi and a few lights for some time now. Right, so we've really developed a new market for lead acid batteries, or for secondhand lead acid batteries. And that market is very well established. And so in the forecast, we see lead acid batteries playing an important role, especially in ESS, mainly because its supply chain is very, very well established. Right, its recyclability is huge. It's over 90% in most places. And the problem is, if we don't use use the lead acid's recycled material, you're going to end up with a lot of lead waste, which causes another issue on a global scale that will need to be addressed. So very interesting points to think about what this landscape will look like looking forward.
Knowles, Charles, yeah, sorry, I hope I'm not interrupting. I'd like to unpack something that Kobus has mentioned with regards to batteries bringing additional value to any enterprise. If I can ask Willem just to put the presentation back and go right back to the end slides, I'd just like to point out something to the audience. Willem, is it possible to quickly call up the presentation and go right to the back to time of use? So yeah, you'll go further back, more. There we go. Thank you. Most of our customers, Kobus, are on time of use system tariffs. This is Eskom tariffs. And please bear with me for those people that do understand this very clearly. But Eskom has got, if you look at the two wheels, Eskom has got winter tariffs and it's got summer tariffs. That's your low demand and high demand season. And then within the two seasons, it's got peak, standard and off-peak tariffs, which are indicated, peak being the red, standard being the yellow, and then off-peak being the green. That's on the two wheels. It's summarized very neatly in the table below, if one looks at those tariffs. And here we can see, for example, a substantial differentiation between peak and off-peak tariffs. If one looks at winter months, on peak, R4.73 per kilowatt hour, dropping to 77 cents in off-peak. And then, of course, in summer months, you'll see a similar differentiation. Now, Kobus, where batteries come in, and this is very, very interesting, the way that Arvi and his team design these systems. If you have a customer time of use, and if it's a customer that primarily uses his power during daytime, what Arvi and them do is to design the battery system to be charged during the off-peak tariffs. So effectively, you would charge your batteries overnight at 77 cents or 67 cents. And then in the morning, if you look at the wheel, when your peak tariff kicks in between 7 and 10 o'clock, those batteries would be used.
Kan ek hom net terugbel? Ek is net in 'n vergadering. Ek sal jou bel asseblief. Ja, okay. Dankie. Bye.
Sorry, John.
Sorry about that, Charles. Carry on.
Then charged overnight at an off-peak tariff, and come the morning between 7 and 10, those batteries would be discharged. It's called peak shaving, but in a case like that, you can just imagine the savings that battery power would bring to the business. Thank you.
Now you just need to hope that Eskom's grid is operating so that this pattern works, right? So you can charge at the right time.
Yeah, there are quite a number of assumptions, but in fact, we've got quite a number of systems that operate in this way.
Yeah. But I think, it points to an interesting point we heard 2 weeks ago that, in order to build a sustainable energy supply on renewables, you need, what was it he's mentioned, a 1.7 times demand in terms of actual supply, which means you'll have excess to sell, which, adds to other costs. And there's interesting solutions here. I think the frustration is like, how do we get these moving? John, I see you've put a comment into the chat. Do you want to maybe, I know Andy's left, but do you want to maybe talk a bit around that?
Yeah, thanks, and apologies for the noise there. I mean, I think it goes without saying that this whole government and municipalities are disappointing in terms of, buying back power and getting the system working in sync. I mean, I do understand, and we've done some homework here on Amanus, who make the Western Cape pretty smart, as they say, but they make a lot of promises and yet to deliver. But they're working on it. The key couple of questions for me, Knowles, to Charles and the team, and thanks, Charles and team, that was excellent. Won't you give us, and we don't want the company secrets, but you showed AfriMat development there. I presume that's one of their new quarries. To roll out effectively a PV and a backup genset system for that, what's the round number capital for that sort of installation, Charles? And then, when you've got time, we should also go and talk to Jim Davidson, because he's got a small, fixed Fisher mine, and he's having huge problems with the cost of gensets and, sustainable power. So we can take that offline. And then my second point is, and we've covered it a bit, is obviously recycling. When we look at what's going on in Wyoming, and big wind turbine blades are now being buried in these massive quarries. I'm not looking for an instant answer, but we certainly need to look at the whole recycling of this either wind and batteries that eventually do run out, and how's that process going? And then my third question, and it really goes back to Anthony Keane. Anthony Keane asked a question in the chat box, are these systems off grid? Well, I think the gist here is that we're not going off grid, because actually there's lots of capacity as these systems get rolled out, and whether it's nighttime or daytime, there will be power that can be sold back into the grid, for the benefit of all. There are townships and hospitals and schools that we also need to keep going. So that's my three sort of points, Charles, particularly for me, just the capital cost. What's the AfriMat capital cost, or a mid-tier mine going to cost to roll out a 24/7 system?
Certainly. Willem is our financial fundi. So Willem, just on Glen Douglas, approximate capital cost for a straightforward grid-tied system.
Right. So the straightforward grid-tied system, so again, taking into consideration what technology you're going to use. So if we take AfriMat, for instance, the tracking system will provide a lot more production than what your fixed system will have. So the 1.6 megawatt system for AfriMat is circa 24 million for that system. It's got a payback between three and 4 years. Looking at phase 2 of the system, and also then when you add BESS to the system, and that's exactly just on the point that earlier as well, I'll be taking these systems off the grid. The financial choice to take the system off the grid doesn't make sense, due to the fact that solar isn't a silver bullet in terms of energy production. As soon as you've got your cloudy weathers and your rainy seasons, you won't have ample amount of energy out of the solar system to charge the batteries. So if you're off grid, then you're facing the challenges to start the generator. And going back to the cost of a generator is, it's R6.40, so it's your most expensive power. So what we're doing with the clients, we are focusing on that should we end up in a phase 6 or phase 7, and we only have 4 to 6 hours power from the national grid, we will have reliable power throughout the day. Now, a system like that, for instance, for the Littleton mine here in Centurion that we also ran the analysis on, was 94 million. So that will include a 2.8 megawatt solar farm, a 6.5 megawatt hour battery bank, and that will supply between 16 and 80 hours of power. So you will have that gap in terms of 4 to 6 hours per day of charging the batteries from the municipal side, because it's still during the nighttime. It's one of your most cheapest forms of electricity. So again, like you mentioned, is selling back to the grid and also assisting is one major part. But what we've realized is looking at our customers is protecting their business. Currently, the solar farms that we're also busy with is actually for clients that don't have available space to install these solar parks, and they need to have reliable power from different sites. But as soon as you go to solar parks, you need to transport that electricity over the national grid that's still held by government. So our main focus is actually phase 1 PV system. That's a 24 million, straightforward. Phase 2 will be the battery system. And should the storage system decrease in the next 3 to 5 years and energy costs rise, that's where we will look at total off-grid systems. But building solar parks on clients' premises, and that's why the mining sector is one of our main focus areas, because one, they're a huge consumer of electricity, and two, there's almost a certainty that you will have available land. So I hope, John, that addresses your question in terms of costing, capital cost, and also then how we look at the systems from off-grid.
That's very useful, thanks. And I think you guys also provide financing, which obviously is for another discussion, but I guess you offer a sort of a one-stop shop.
100%. So
John,
that's the focus that we're on in terms of what we've seen our clients. As soon as you get to phase one, it's I won't say lower amount, but the clients are more than happy to finance them themselves. But as soon as you start adding your batteries, it gets much more complex, and also then the O&M of those systems. So the clients will usually say, come in and become an energy supplier to us. We will purchase energy from you that we can state will be reliable, and also that you're not as dependent on the national grid.
Excellent, thanks.
So John, to summarize that for you, and this is rule of thumb numbers, a standard solar installation, this is an industrial installation tied to the grid, would be anywhere between 13,000 to 15,000 Rand per kilowatt. If it becomes medium volt, where you've got to supply substations and major switchgear, you could start looking, it will increase to around about 20,000 Rand per kilowatt. That's a sort of, rule of thumb. Coming to your last question with regards to environmental and recycling, certainly for future entrepreneurs, recycling of battery systems and solar panels in order to remove all the precious materials, that's certainly a business for the future. We were at the solar park the other day, and they had 201 rejected solar panels. These panels were broken, and their quote to have those panels removed and recycled was $1 million. So it's definitely going to become a industry for the future, similar as what platinum is removed from the from the motor vehicles, from the catalysts. We'll see something very, very similar here.
Thanks, Charles.
Yeah, I mean, if I may add to that, we were looking at some of these recycling solutions when we're looking at what do the supply chain forecasts look like by 2050, and one of the challenges that we've identified, which is potentially unique to the solar industry, because there's very much a sort of batch installation, right? It's not a steady flow of supply and demand and building and recycling. So the key issue is going to be with a steady inflow of end-of-life panels for recycling, which means that the actual recyclers' economy of scales doesn't work. So it's really just going to be a short-term operation, and longer term they'll go bust, i.e. so recycling solar panels seems to be, at the moment, the outlooks are in any scenario won't be profitable. So it's a cost-bearing process, and so really what that may mean longer term is that the governments and whoever's responsible for these will need to think about that longer term. Much like you said, John, we're burying wind turbine blades. This is an issue longer term when we're starting to talk about the scale up in these industries is massive, and the waste that comes out of that. So it's a key issue. So just wanted to add that. But my one takeaway sort of from your comments about the costs coming into this, and please correct me here if I'm wrong. So are you saying, developing the systems to get your operations, etc., sustainable is one thing, but then feeding back into the grid and effectively being the good Samaritan and contributing is then that's a big extra cost. Did I understand that correctly?
Knowles, no, if I understand your comment correctly, most of our systems are tied to the Eskom grid.
Okay.
Eskom has got two offers for feedback into the grid. One is called small scale embedded generation. That's for systems below 500 kVA. And then they've got another offer for systems above 1 megawatt. These offers work we've done approximately 12, Willem helped me, about 12 installations where our customers are feeding back into the grid. In our financial models, we do not provide for systems feedback, so it's an extra bonus for the customers. And also at this stage, the Eskom tariff is a 1-to-1. So if your customer pays R1.70 per kilowatt hour, then all the surplus power that's generated on a weekend, if it's only a Monday to Friday business and public holidays, all that surplus power is fed back into the grid at an equal tariff, in other words, R1.70. Eskom obviously does not pay cash for this power, but they do provide credits. So if we have a customer, and a farmer is a very good example where the user is cyclical. You've got your cycle of soil prep, then for planting, and then for harvesting. 3 months in the year during the harvest period, obviously maximum power usage. The other 6 to 9 months, very, very little. In those six to 9 months, that solar plant of his is running at full power. It's feeding back into the grid for credits, which is then used during the 3-4 months of harvesting. And we've got quite a number of clients that we can use as examples that use it this way. And it's really to their benefit. And I can really say the Eskom offerings, it's called net metering and banking. The Eskom offerings really, really do work. Ekurhuleni municipality has now jumped on the bandwagon. And Willem, they are offering, just give me the tariff for feedback into the...
R1.11. It differs from your high season to low season, from 85 cents to R1.11.
And Willem, just added to that, have we seen other municipalities offering now the same sort of feedback?
So we're busy. There's a lot of development coming in, but the main ones in Gauteng was Ekurhuleni that did the first jump. Tshwane is busy with the process, but it's not in as yet. City Power is also considering it. KZN has got it published in their tariff books, but when you give them a call, try to do their applications, they're not aware of it. So there's a lot of movement going on. And the Western Cape, I mean, I think all of the Western Cape municipalities are also allowing feedback power. But outside Western Cape, we're seeing a movement, a clear movement, but not as quickly as we would like.
Yeah.
Thanks, Knowles.
One thing just to take in consideration, sorry, just on top of your thing, Charles, the PV system design is not solely, actually, you don't need, if you base the PV design on feedback and selling of electricity towards the national grid, you also run a huge risk. In terms of that tariff is not fixed for 25 years. That tariff is reviewed every single year and also published again. So Eskom currently has a 1-to-1 ratio in terms of the credits. So it's not actually a buyback, it's credits. As soon as you push back electricity, you can get your credits at a later stage. They are in 3-4 years' time, I mean, that can change to a 50%. I think it was Drakensberg municipality that we realized when they started this entire process of buying electricity back, it was a huge sweetener in terms of credits. I think it was here around about 90 cents or R1. So apologies if I'm out by 10 or 20 cents. And then 3 years later, they dropped it to 60 cents. So the system design that we're focusing on is first of all for the customer's consumption. And then should there be additional excess, we can feed it back. But on your question also in terms of being the good Samaritan, what we've seen, especially in the mining industry, you've got a lot of rural areas surrounding the mining industry. And as part of good corporate governance, what a lot of these clients are also asking us is, instead of feeding the electricity back into the national grid, can we build overhead lines and also feed the communities with power? So there's a lot of spin-offs from that. And if you look at your life of mine, if your life of mine is, for instance, 20 years, and the solar system, I mean, a panel is warranted for 25 years, but all this panel is currently 60 year plus, still in production. So what they're also saying, after the life of mine, in terms of rehabilitation and also good corporate governance, that plant can be carried over towards the community and supplying them with power. So there's a lot of things that you can do with the planning of these PV parks.
Yeah, no, absolutely. I think, yeah, there's a big drive of this renewable energy. It's interesting to see the drive in South Africa is for different reasons compared to the rest of the world. But yeah. I see, Elizabeth, we've got a question just here on sort of, the whole drive of this green economy requiring raw materials. And I think that's a whole conversation in itself, but you're absolutely right. As this demand ramps up, battery energy storage, these are all key supply chains that need to be looked at and are based on these technologies using metals that aren't gold or PGMs or copper or aluminium for that matter, which are also used, but they're requiring new metal markets to be established. So I'll leave a lengthy answer to that for another time. Happy to follow up on that. Yeah, so I think with that, John, do you anything else you'd like to add? Maybe we can wrap it up.
Alan Roxton Wiggle had his hand up. I don't know if you finished.
Please, yeah. Alan, would you like to unmute yourself and join? Alan?
No.
No?
Okay.
Yeah.
Sorry, I lost. I went off screen. I lost my mute button. No, I was just curious to find in that presentation there was a quote price of 35 to 55 cents. I'm just not entirely sure, other than on mass scale rollouts, that's possible. So I'm very interested to chat to this company about what they could do for my CNI clients. So they're welcome to contact me. Thank you.
Yeah.
And thank you, Charles. Yeah, John and Henny has got our contact details. If you don't mind, through them to just supply us with your details, and we'll be in contact with you. Just with regards to those numbers, and this is more on the lighter side. When we approach new customers, obviously we quote the numbers that Avi had highlighted in his closure. And I've heard so many clients saying to me, Sunrange, I've seen this before. It sounds too good to be true. Sunrange, this is a scam. This is a Ponzi scheme. And we can understand if people are skeptical, given the amount of malfeasance that's going on there. And I guess our response to that would be, Mr. Potential Customer, we've got 110 installations for 210 megawatt. Those customers are open to you in order to contact them and do your due diligence and establish whether our claims are really trustworthy. But please let us have your contact details, and we would love to engage with you. Thank you.
Excellent. Thanks, Charles and team. Appreciate that. Right, so I think that sort of closes it up for the green energy sessions and November. It's been a real pleasure to talk about sort of the opportunities and challenges in South Africa and Southern Africa as a whole, and where that sits globally. Definitely not the last time we'll be talking about this. It is an ongoing conversation, and as we've seen, the raw material requirements are a massive growth area on this. John, when you're done with your call, maybe you want to just lead us into December there. John will be chairing the next few sessions. Let me just pull it up on my screen so I know what I'm talking about quickly. Right. John, can you lead us into next month? We've got 2 more sessions left for the year. If you want to just give us a roundup for that, what to expect.
Yeah, thanks, Nelson. Thanks everyone for the great presentations. And I guess we will do it, but thanks to everyone through the year for a wonderful, set of presentations. And as we all know, presentations like this take time and effort. And I can continue to learn about this amazing profession of ours and everything that goes with it. So thanks, Charles, and your team today, and everyone else previously. So we're now sort of at the end of the serious stuff, and Henny can add when I'm finished. And we're going, back to some lighter geology, but important geology next week. Greg Buerta, who's just recently retired from the CGS in Maritzburg and a wonderful field geologist, he's going to be talking to us about land surfaces across this country of ours. And over the years, he's done some wonderful work all over the country. And, we don't realize how important these young land surfaces and long periods of erosion are for, mineral deposits as one example, including, for example, alluvial diamonds. So Greg Butch is next week, and then the last presentation of the year will be Pete Siegfried, who's an expert on how geology impacts our whiskey qualities. So we'll be looking forward to that one as well. Sort of light relief leading up to Christmas. So again, thanks everyone. Henny, have you got any comments?
I'm fine, John. Thank you.
Right, and thanks to Henny and the rest of the team too. He's also been a stalwart through the last, what's it now, 3 years, with all his regular updates and reminders to people and keeping our master list going. So yeah, thanks to Henny and the team as well. All right, Nils, I'm done.
All right. Thank you all. Appreciate your time. Have a good rest of your Thursday and into the weekend.
Thank you, everybody. Thank you very much for the opportunity. Have a great day.
Thanks,
Thanks,
Charles.
Charles. Thanks.
Bye-bye.
Thank you so much, everyone.